Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich from Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, Captivate, or wherever you get your podcasts. Now, listeners know that typically we talk about the HVAC and refrigeration industry on this show, but as Monty Python would say, now for something completely different. And today we're going to be talking with Luke Wadsley, who's Director of Engineering Solutions at Danfoss Power Solutions, and he's here to talk to us about digital displacement and how it's helping the construction industry increase efficiency while lowering carbon emissions. Luke, thanks for taking the time to join the show.
Hi, Vic. Thanks for having me here.
Can we maybe start with a little bit of background and tell us about your work in off-highway machinery and hydraulic systems?
Yeah, I've worked in the mobile hydraulics industry, now Danfoss, for 25 years across areas of component development to hydraulic systems. I'm especially passionate about kind of helping our customers learn about and implement new technologies that enable significant value, especially the practical end of research and development per se, and digital displacement technology. It just lands right there for me.
Since we're typically HVAC refrigeration type show, maybe let's start for the listeners. Can you help ground us all a little bit and define what you mean by digital displacement?
Yeah, digital displacement pump, it's very new. So it bears a little bit of explanation as well. It's the only truly digitally controlled hydraulic pump for off-highway machinery. Mechanically, it's simply a radial piston pump, but it has a dedicated microcontroller that activates each piston individually. And that provides very fast and accurate responses to system demands. And then that flows up into superior machine controllability. So the pump provides very high efficiency by using only the pistons that are needed to meet the load. I like to think of it as a kind of carburetor to fuel injection change in the hydraulic pump world.
Okay, so we're talking about really the heart of the hydraulic system on a lot of these off-highway machines here. So I was trying to do a little bit of research ahead of time on the topic, and something that really struck me was the CO2 emissions out of the industry here. And for the construction machines, we say that they emit about 400 megatons of CO2 per year globally. So that's a big chunk of the overall picture. So as the expert here, is that an accurate number? And where do you see the best opportunity that we can lower emissions?
Yeah, that's right. Construction machines, they specifically have a huge CO2 footprint. I mean, you see them everywhere you go, and they work really hard. And of those construction machines, hydraulic excavators really stand out. Hydraulic excavators themselves are responsible for roughly half of those CO2 emissions. So that's 200 million tons. Or the equivalent of 16 billion gallons of diesel fuel every single year. So here in Iowa, if I was to go buy that diesel fuel at today's prices, that's about $60 billion worth of fuel. And over 90% of excavator emissions come from the larger machines, so larger than about 10 tons. So no matter how you slice it, that's a lot of money, diesel, CO2. So when Danfoss is looking to make a big dent there, focusing on these larger excavators just makes a lot of sense.
And maybe just for grounding, I also checked on the commercial building side. So since that's kind of my background there, the commercial buildings globally are about 10 gigatons, right? So something like, so we're talking about 4% here just in the excavator. So, I mean, it really is a big number because we know the commercial buildings are a significant part. And I was super surprised what big a number we have there on the excavators. And of course, with all the CO2 output, one way to reduce the fuel that you were using, of course, is to make those excavators more efficient, right? And so energy losses in the hydraulic system are a big concern, both from emissions and, of course, a cost standpoint, as you mentioned. So what causes the losses today, and how do we minimize them, and why is it so important to do so?
Good question. The hydraulic systems of excavators today are really only about 30% efficient. So 70% of the energy coming into the hydraulic system is wasted in the form of generated heat. And this materializes from pump inefficiencies, throttling in the main control valve that sends flow out to the individual consumers in the excavator, especially during simultaneous operations like stick out and bucket in the dirt, for instance. And then also there's lost recoverable energy. So I think of like the boom coming down or swing decelerating is just energy that's lost that you could somehow capture otherwise. This stuff isn't new. Like I said, these hydraulic systems haven't changed much in the last 30 years. But if we can minimize these losses, we can not only reduce emissions, the CO2 emissions we just talked about, but we can lower energy consumption, improve those operating costs for the owners and operators, and also be more productive.
Well, I guess the upside is with 30% efficiency, there's lots of upside potential to turn the things around. So when we talk about digital displacement, how does digital displacement and other technologies, how do they help make construction machinery more efficient, right? How does it all work?
Digital displacement technology is really at the core of what we in Danfoss have branded Dexstream systems, which we've demonstrated them on machines to improve excavator efficiency by up to 50%, regardless of the power source, whether it's an electric excavator or diesel or alternative fuels as well, all while maximizing productivity. So the way that it works is we've kind of defined these three different Dexstream system types. On the simple end of the spectrum, there's swap, then there's flex and max, which become a bit more complex, but with increasing value. So if I start with the Dexstream swap end of the spectrum, it's the easiest configuration, essentially replaces the excavator's main hydraulic pump with a digital displacement pump, along with some control system work. And that gets you about 15% reduction in fuel use and its associated CO2 emissions compared to the baseline machine. This Dexstream swap system makes significant engine downspeeding possible without the risk of stalling the engine, which is an issue in conventional systems today. In addition to reducing the fuel consumption and emissions, this decreases noise by bringing the engine speed down, improving the operator comfort. And then if reducing cycle times is more important to the machine owner than fuel consumption, the system can deliver up to 25% higher productivity by better utilizing the same installed engine capacity. So yeah, it's a pretty easy way to enter into a Dexstream system without a lot of work. You're just taking the pump out and putting the pump in with some control system work. Now, beyond that, the more complex systems, Dexstream Flex and Max, they build upon that swap system to provide some additional gains. So Dexstream Flex dynamically allocates the pump flow to the services based on demand, reducing throttling losses in the main control valve. That's really attacking that throttling issue that we talked about earlier. And then the Max system adds the functionality of energy recovery from excavator motions like swing, deceleration, and boom down, as well as direct load control from the pump itself. So the pump can basically control the actuator without utilizing the main control valve in the middle. So those two systems, Flex and Max, they get energy savings in the 30 to 50% range, respectively. And they're still in development, but we've demonstrated some of those features for sure on real excavators as demonstration machines.
So then with those tools, then we can go, if we said 30% efficiency today, we can get up to close to 50% efficiency then with the new solutions, right?
That's right.
Wow, super impressive. So you mentioned some things are still in development, some things are out there in the field. Can you give us some insights? Where has digital displacement been deployed so far? Any case studies or references to show?
Yeah, I'd really like to talk about is we've got a field trial that's ongoing in the United Kingdom right now with 3 20-ton diesel-powered machines. They're Volvo EC200s. They're equipped with the Dexstream swap system, so this kind of simplest implementation. We did that in collaboration with the UK Volvo dealer named SMT and are being operated by the Ashport Group, which is a building materials supplier. Those machines are well on their way to this 2,000 hour mark, which we should hit sometime this summer. And our goal is to really see how they perform in a kind of tough quarry environment and to get operator feedback, which it's been great to hear so far. They kind of uniformly are pretty positive. They've commented that the machines are responsive and strong. They dig like larger machines. They also seem to favor the productivity mode, the kind of rabbit turtle on the dashboard. They tend to leave the switch in rabbit mode.
Very nice. Now, in your opinion, why hasn't digital displacement been implemented on a broader scale? What are some of the barriers that we have to adoption?
Yeah, that's an important consideration. Excavator manufacturers are understandably cautious about new technology. After all, these machines are intended to be very productive. So high uptime is paramount to getting their work done. So digital displacement systems, in addition to showing that they're highly productive and have good efficiency, they have to be extremely robust, mechanically, hydraulically, electrically, even the control software, just as good or better than the existing hydraulic systems, and proven in the field as well. So OEMs need to understand these aspects to be comfortable, and also how to integrate the control system, how to service them, take advantage of all these new levers that digital displacement brings to the table. Maybe one other comment is, because the excavator industry is so large and stable and mature, cost has had a long time to be optimized. So something as disruptive as these digital displacement systems has to show clear value to everybody involved, the OEM and the end user. And it just takes time for that message to resonate across.
Right. I think in all the industries Danfoss serves, it's always kind of the challenge, right? Nobody wants to start using a product until it shows years of reliability in the field, right? But it's kind of hard to get the reliability till somebody starts using the product. So, but how can manufacturers like Danfoss work with OEMs to address some of those barriers? You mentioned field trials that we're doing. Is there other things that we can do?
The word that comes to mind for me is just engagement. We've got Danfoss people around the world who really know digital displacement inside and out, and have been actively working with OEMs, partnering together to kind of grow our collective knowledge about what works well in these excavator systems. And I would say that the stars are really aligning. I mean, market forces have been really nudging end users and OEMs to make these meaningful changes in order to remain competitive, like corporate science-based targets for emissions in product and use type emissions, 2030 and beyond, as well as electrification. There's low or zero emission construction zones legislated, rising energy costs, other legislative forces as well. So you're kind of starting to see in areas like electrification, where there's a lot of value, that's kind of chipping away at what's conventional in the marketplace.
Yeah, and I have to mention, you mentioned the $60 billion of fuel cost savings probably turned some heads too, right? It's always nice when you could put a real number in front of customers like that, right? And if you're showing such significant improvements, right, that's something nice to motivate them to get looking at it. Yeah. So we talked about diesel fuel and the costs associated with it, but isn't the market heading more towards fully electric? And that's kind of the direction people want to go. So how do you see this? Is this a step towards that full electrification? And is that a realistic goal that we can expect in off-road machinery? And what kind of infrastructure and incentives do we need to kind of get there?
It's definitely a hot topic. And electrifying construction machinery is clearly happening in areas where it makes sense. And it's, like I said, it's a valuable tool to reduce emissions at the point of use, but it has some big barriers for large-scale adoption in construction. Some examples are just the cost and supply of these batteries. Because they're such high utilization machines, the costs for an excavator can easily double from their diesel burning counterparts. That's a big barrier. There's some programs like in California where they can kind of help offset those costs, but it's still, somebody's paying for those batteries one way or the other. Lack of charging infrastructure is a big one. You imagine building an interstate. There's not a lot of places to plug in your electric excavator along the way, and dragging a large diesel generator along the side to charge that thing. Also, the optics don't really work very well either, right? So we got to address these things, especially for hardworking equipment like excavators, to make them economic and environmentally friendly as well. So to me, things like digital displacement, they make a big difference, kind of low-hanging fruit in terms of making it more feasible to electrify those types of machines.
Right. If you don't need as much power going in, then the ability to electrify just gets that much closer, right? I saw, there's actually an article today I was looking at talking about some electric equipment in a mine in Australia, and they said the equipment had a 2-kilometer long cord, right, going back to the and I guess in a mine that's okay, right? I mean, they're not moving that much, but right, that's a heck of an extension cord, right, to plug those things in. Yeah.
Right.
Yeah. So everybody's trying to get to electrification and get that next step, but what other technologies do you see being developed in the future that can help bring about a green transition in your industry?
Clearly, we'll take a variety of tools to make those transitions a reality. We've already kind of hinted at, alternative or low carbon internal combustion fuels that don't have the same kind of carbon footprint, more availability of renewable energy, corresponding grid scale energy storage solutions. So you can charge those electric machines when the sun doesn't shine and the wind doesn't blow. And then also continuing to attack the wasted energy in those systems. Digital displacement is one way, but another example that comes to mind is independent metering valves in the hydraulic main control valve. Another good example, existing technology that can be implemented today to reduce those throttling losses. So Danfoss and others in the industry need to continue to invest in these, both the development, but as well as the deployment of those solutions, not just to make them environmentally positive, but also to remain relevant commercially.
Yeah, interesting. I think that's one common theme, no matter the topic, no matter who we're talking to. The answer is always lots of stuff, right? I mean, there is no one silver bullet that's going to go out there and suddenly solve all the world's problems, regardless of the industry we're in. There's lots of small incremental gains, and some gains will be bigger than others, but every solution is unique. Every application is unique. And so there's lots and lots of different things that need to all kind of come together and be applied smartly to make the equipment do what we need it to do. So if it makes you feel any better, right? It's right up there with everybody else fighting those same kinds of battles, right?
Right.
Yeah, exactly.
Takes a village.
Yeah. Of engineers, right?
Yeah.
So is there anything else from the technology or decarbonizing construction equipment standpoint, or anything in general that we didn't talk about that you'd like to mention to listeners?
Danfoss has this tagline, the greenest energy is the energy we don't use. To me, it really resonates with these kind of themes, electrification and reducing waste. I mean, it's also the cheapest, right? So whether you're interested in improving the environment or being productive, being successful commercially, it just makes a lot of sense to decarbonize and reduce wasted energy, right? So I think as long as we continue to sustain our curiosity and investment in these types of things, it'll move the ball down the field.
Clearly, we can tell you're passionate about the topic here. And as this is a pretty new topic for us on this podcast, can you maybe point our listeners in a direction where they can learn more about digital displacement and other technologies, maybe learn a bit about the field trials that you're doing right now?
Yeah, we have some really good information on the Danfoss website with links to that field trial, as well as product information and some other studies as well.
Okay, fantastic. Then we will definitely put a link to all that good stuff in the show notes. Thanks, Luke, for joining us today.
Yeah, thanks, Vic. Much appreciated. Subject I'm very passionate about.
That's it for this episode of EnVisioneering Exchange. Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, Captivate, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.